Welcome to class number 5 of Python level 1. So we're more than halfway through, which you should be proud about. Right. Hi, Mason. See your message in the chat. And I'm going to start with my screen share right now. So here I have a little bit of a review for last week. Last week we finished up our discussion on strings, which is just how you store text in Python. And so I thought I'd go over just a quick couple of concepts because we're going to find them useful in today's lecture as well, even though I promise we're not going to talk about strings past the first 5 minutes. Okay, so if you're tired of strings, don't worry. We're going to be over them very shortly. So again, how you create a string, you just use quotation marks. You can use double quotation marks. You can use single quotation marks. And this just creates a string object that you store into a variable. And the things that I really want to make sure we understand are how to access a string at an index and the idea of slicing a string. So for the first one, can anyone tell me what this first statement is going to print out? What is my string at index 3? What is that going to be if I run this cell? Oops. So Derek says E. Anyone else want to give an answer? So let's get 2 or 3 responses for this. Amy says L, so we have a little bit of disagreement, which is fine. Does anyone want to break it? Okay, so Derek says L again. And let's just make this clear. Is it going to be the first L or the second one? I mean, the print statement won't be different either way, but is it actually the first one or is it the second one? So Derek says it's the second one. Amy, do you agree or disagree? Is it the first L or is it the second L? Like I know the print is gonna be the same, but it's important to know which one it is. That's actually kidding. Yeah. Okay. So I agree with all the answers. Let's see. So I see what happened there. All right. So yeah, these were just comments that I had just to put a bullet point of what's going on. But yeah, so I agree with what everyone has said in chat. This is going to print out L, and it's specifically going to be this L. We know that because string indices start at 0. And that's the important thing. I think I've said that enough already. But here, this is index 0, the H. The E is index 1. The first L is index 2. And the second L is index 3. Notice the third index is actually not the third letter. It's the fourth letter. And again, that's all just because the indices start at 0. So it's kind of one off. Now, very similar, but here is an example of slicing a string using the slice notation. No problem, Evan. I'm sure your other classmates can agree that they've done the same thing. I know I've done the same thing a lot. It really takes some getting used to. But the good thing is that in a lot of programming languages, or if you're just using Python for a while, you really get into the hang of it and it starts making a lot of sense. And it's kind of like at this point, when you start counting at 1, I feel odd now if you're saying the first index is index 1. That just feels wrong to me. But some languages do that. Python, however, does do index 0 as the first index. All right. So the second question is this accessing a string slice. So here I'm doing my string and I'm doing :3. So first you have to remember what is a slice. Do you include the first? Do you include the last? And Also, what happens if you're not giving one of the positions? So maybe I should have been careful. So I know, Derek, you were not saying a bad word, but you were trying to answer the question. Um, so we have the first four letters. Mason says LL. Anyone else want to give an answer to this? So I guess actually let's break this down really quickly. So notice I didn't give a starting index to the slice. So can anyone tell me what this statement is equivalent to? Like what number should I put here? That would not change the meaning. Okay, yeah. So if I don't give the starting index, it's just as if I put 0 there, right? So I was just lazy. I didn't put a starting index. Python just assumes that you mean the start of the string, which means index 0. So now I have my string from 0 to 3. And so I'll give a hint. The correct answer has not been in chat yet. And so I see one new response. ELL is one response. You're very close, but I think you have it flipped. Yeah, HEL. I agree with HEL. Maybe I should have been a little bit careful with my string, but yeah. So slicing, it's very similar to indexing because you're using a start and end index. But the important thing that I want you to remember is that the stopping index, the second one, is not included in the slice. So it's kind of a trick here. When you access an index 3, it gets whatever letter is at index 3. When you do a slice that ends at 3, however, it doesn't include it. It goes up to, but not including the second number, right? And so if, for example, I wanted the word hello, I would want to go up to, but not including the space. And so here it's index 0, 1, 2, 3, 4, 5. So if I want to get the word hello out of my string, I'd want to go from 0 to 5. Right? Even though 5 is the index of the space, this goes up to, but not including the space. Okay. And finally, had this on my PowerPoint, but I won't flip to that right now. Here's kind of a multiple choice question. I have 2 lines of code here. One of them is valid Python code. One of them is not correct, and we'll give you an error. So does anyone remember how to find the length of a string? Is it the first one or is it the second one? It's one of these 2. Line 3, Derek says. So this is a little bit of a tricky one, and I'll do my best to explain the answer later. But does anyone else want to give an answer? Do you agree with Derek? Do you disagree? All right, so here is not the answer, but here's the difference between these 2 statements. So let's look at line 3 first. So if this was the correct answer, I'm not saying if it is or not, what this is saying is that this len function belongs to the string. And so when you say something dot len, it's basically saying the function belongs to whatever's before the dot, and it's whatever's before the dot is doing the function. And so the difference in line 2 is now that instead of my string being in front, it's being passed in as a parameter. So it's being, it's an input to the function. So it's like, instead of doing the function itself, it's being acted upon, right? So now in this case, the person or the the object that's doing the function is actually like, you can think of, I don't know, like Python itself as one way to think of it. So let me give a few examples of what I mean. We've seen like upper and lower. And so those are ones where you do things like my str.upper. This is a valid function right here. There's also the lower, there's replace. And those are ones where the string is the one doing the action. So here, the string is calculating the uppercase version of itself and returning the result. It can do the replacement and return a result, things like that. But for len, it's one of the few functions that was different. The correct version is actually line 2. So line 3 is incorrect. Line 2 is the correct way of calling the len function. And so one way you can think of it is that also this len function doesn't apply just to strings. So it doesn't belong to the string class. It belongs to something else. What this means is that not only can you find the length of strings, but you can also find the length of other things. And specifically in today's class, we're going to talk about lists, which is another thing where you can find the length of. And what you do is you just do the same thing here. You do len, and then you pass in your list inside the parentheses. The reason why like upper looks like this, on the other hand, where you have the dot upper, that's just because the upper function is kind of something specific to the string class. And it's not something that like a list could do or a number could do. It's only something a string can do. And so len looks like this, where you have len and then you have the string inside. Upper looks the other way, where you have the string and then dot upper. So that was a little bit of a tricky thing, but we're going to see a couple more examples both today and in the remaining classes of this, kind of different versions of this. All right, kind of a bit of review, but also kind of something new was our discussion of Booleans. So that's where we left off last week, where we introduced what Booleans are in Python, what they look like, some of the different operators. And so just to recap really quickly, Booleans are a very simple data type. They are hold the value true or false, only 2 values, right? And we have, where it gets a little bit tricky is the operators and figuring out how they work, I guess. And so I have a couple practice problems, and I'll do the first 2 together, and then I want help with the last 3. So what this is doing is you don't see true or falses in the first couple, and that's just because the Boolean comes from evaluating this relational expression, right? You have this 3 greater than 4 expression here. You're using one of the relational operators, greater than, less than, greater than or equal to, less than or equal to, equals, not equals. Those are all different relational operators. And so here we're using one, comparing 2 different things. And the result of this comparison is going to be a Boolean. So if we do 3 greater than 4, hopefully it should be obvious that this is not true. It's going to be false, right? So 3 is not greater than 4. So we can essentially replace this expression with a Boolean false, right? Because they're equivalent. 3 greater than 4 is equal to false. And then what we have is just a not operation. And if you remember from last class, not just flips the result. So what is the opposite of false? It's true. Yeah, exactly. So this is going to be equal to true. Yeah. If we look at the second one, it's actually a little bit tricky. I didn't realize it. It's something I haven't talked about yet, but numbers have a way of converting themselves to Booleans. A lot of different data types have a way of converting themselves to Booleans. And generally the rule is if you're empty, and I'm doing that in quotes because I'll explain what that means later. If you're empty, you're false, and otherwise you're true. So almost everything is true except for empty values. And so for numbers, an empty value, maybe you guessed this, maybe not, it'd be a 0. So 0 is false, everything else is true. So 1 is true, 5 is true, 100 is true. It's only 0 that's false. For strings, for example, the empty string where you have nothing inside, that's false, and everything else is true, right? So there's ways of converting from other data types into Booleans. And so here, when we do 1 and 1, since we're doing this AND operation, we need to convert either side to Booleans. So when we convert 1 to a Boolean, you get true. Oops, type too fast. When you convert the other Boolean to true, when you convert the other one to a Boolean, you also get true. And then here's where we use one of the first Boolean operators, and. So and requires both sides to be true for the whole thing to be true. The other Boolean expression is or, and that is less strict. It only requires one of the sides to be true for the whole thing to be true. So here we have an and, so we need to check both sides. We look at both sides, they're both true. So the whole expression is true. And just like what we saw before, not flips the result. And so not true is going to be false. So to recap, this becomes false. So now we have other ones. So can anyone tell me what this expression is going to evaluate to? It's going to be true or false. So there's only 2 possible answers. So Derek says false. Let's get 3 answers in chat before I reveal. So Mason also says false, and Amy says false. All right, so how about Mason? Can you explain to me why this is false? Like break it down, the left side, the right side, and then doing the AND operation. So you can either unmute, or I'm guessing you're typing right now. I'm happy to give you a little bit of time to type. All right. In the meantime, I'm gonna write some stuff in my Python notebook for the Booleans. I'm just gonna copy over the stuff we already did. So here's the first one. It's true. The second one. False. And the one we just did. Let me check. Okay, so Mason, you typed it out. You said 9 is not less than 0. So this is false. You said this one is also false. And so for and to be true, for an and expression, you need both sides to be true. In this case, we don't have either side to be true. And so this is definitely not going to be true. This is definitely false. And so exactly right, Mason. One kind of trick that Python does is that it will evaluate this expression left to right. And so it will try to evaluate the left side first. It evaluates this and finds it to be false. And what Python does is it says, hey, I know the left side is false. I don't need to check the right side. Can anyone tell me why you don't need to bother with the right side when you already know that the left side is false?
Because and both sides have to be true.
Exactly, right? So it doesn't if the left side is already false, you don't really care what the right side is, because no matter what it is, the answer is still going to be false, right? And so that's something called short circuiting. And basically it's just like you're doing it halfway and you already know what the answer is going to be, so you don't bother computing the rest of it. And this is kind of a feature, and some people use it to do like checking for empty values. So for example, you could have something like on the left side, you could say X is not empty or not null, or basically it's not missing. And then on the right side, you're going to do some sort of calculation or check on X. And what happens there is that if Python is running this and it finds out that X is missing, then the left side is going to be false. And so it doesn't bother doing the calculation on the right side. If it didn't do this, you might get into trouble, because if you're trying to do calculations on an empty value, you can get some errors. And so the fact that Python does this short circuiting, where it only evaluates as much as it needs to, can actually be a benefit sometimes. There's actually an equivalent to this for OR statements. If you're evaluating an OR statement and the left side is already true, you don't need to bother evaluating the right side, because just like with AND, for OR, you only need one side to be true. So if the left side's already true, it doesn't matter if the right is true or false. The whole thing is going to be true anyways, right? So it's kind of the same logic. It's the same short circuiting pattern. Anyway, let's go over the next couple quickly, I guess. What is this fourth one going to be true? Okay, so I think people already had it ready, true. And this is kind of the short circuiting I was talking about. 9 is greater than 0. So the left side is true. We don't really care what the right side is. It could be true, it could be false. We don't care. The whole thing is going to be true anyways. And the last one, true or false and true. So Amy says true, Derek says true. This is true. So this is just testing OR. Very similar to this one. The thing in the parentheses is going to be evaluated first. So order of expressions. Parentheses do apply still. The thing inside the parentheses is evaluated. That's true. And then you AND it with true. So both sides are true. The whole thing is true. We're going to see more applications of Booleans later on. But that's all we're going to talk about for this class about Booleans. We're going to see it a little bit more next week, I believe. Although I do want to show off that like converting from strings to Booleans or numbers to Booleans or whatever, I want to show that off really quickly. So for example, let's just remind ourselves of this variable I already had, my string. Right? I have this variable, my string. If I want to convert this to a Boolean, the way I would do that is by using, let's say, b equals the bool function. Right? So bool my str. And so this looks very similar to how like the len function looks, right? It's not my string.bool, it's bool and then passing in my string inside of it. And now if we print out b, you can see it's true, right? And we can play around with the bool function a little bit more. Bool, let's just print out bool of, bool of 5, that's true. Bool of 5,732, that's true. Bool of -5, that's true. But bool of 0 is false. So basically anything that's not 0 is true. Anything that is 0 is false. So that's for numbers. For strings, I can have pretty much any string I want. It's going to be true. But if I have the empty string, which just means nothing inside the quotes, that is going to be false. So again, basically anything that's like empty, missing, that sort of idea, those are called falsy values. They're not false because they're not Booleans, but they can be converted. If they're treated as Booleans, they would be treated as false. Then there's the truthy values where it's not true, it's not a Boolean, but if you convert them into a Boolean, it would be true. So you have falsy values and truthy values. Like just in case the audio is not super clear, it's like falsy and truthy. So they're not false and true. They're kind of like false and kind of like true. And that's just because they're not Booleans directly, but they can be converted into such. And this is something that isn't really unique, but it is something special to Python. Not all languages have this. And because of this, you can do some sort of like shortcuts sometimes. You might have heard in Python, sometimes you can get like really compact expressions, and sometimes this truthy, falsy stuff is kind of exploited, taken advantage of, and allows you to like compress your code a little bit. All right, well, let's keep that around. So now I want to talk about lists. That's the main topic for this week. And the first part is actually going to be very, very similar to stuff that we already saw with strings. And so that's kind of why I did the review. But really quickly, first, let's come up with the definition of what a list is. So a list is just a data type that contains other data types. And because of this, we call it kind of like a more advanced type, because it's we have like a basic types are strings, and now we have data types that include those inside of them. So a list is really, really versatile. It's really, really useful. It's basically just a collection of other variables. And what's special about a list is that it has an order to them. So there's a first element, there's a last element, there's a fifth element. You can number them. And the list can be any size that you want. You could have one item in the list. You could have 100 items in the list. You could have 0 items in the list. The values inside the lists don't have to be the same type. So inside of a single list, you can have a string in there. You can also have a number in there. You can also have a Boolean in there. Okay, so it's very loose. There's very few restrictions to lists. In fact, you can even have lists inside of lists. It's a little bit more of an advanced topic, so I'm not gonna spend too much time on it. But you can think of it as a list is a one-dimensional thing where you just have like one item after another. But if you have lists inside of lists, it's kind of like a 2D grid almost, right? So a list is like a row that you fill items into. A list of lists is like a 2D grid where you have like a row and a column that you put things into. So really quickly, the last thing on the slide is how do you make lists in Python? You just use square brackets and you put the values in separated by commas. Right? So this is how you instantiate a list. You declare a list. So I can say my list is equal to, I can put some numbers in there. I can put a string in there. I can put a Boolean in there. Right? So this is a list of 4 items. And once you create the list, you can do a lot of the things that we've done with strings. You can access things at different indices. So if you had to guess, what do you think is the item at index 2? So if I want to print my list index 2, what do you guys think that this is going to be? Based on what you know of strings. So Amy, I think you're jumping ahead, but I like what you're thinking. Derek says hello. I agree with hello. So this one is not getting a slice yet, but we're actually going to talk about slices. This is right now just accessing one item at a particular index. And so just the thing to remember, just like with strings, just like any time that you use indices, you start at 0. So if we're trying to get the index 2, that means the third element, because this is index 0, this is index 1, this is index 2. Right? So with strings, you're going character by character. In a list, you're going item by item. Yep. So here, it's similar, but not exactly the same. Here, it's going to get hello because it's the item at index 2. If we change this number, if we change it to 1, for example, then we'd get the number 2. If we changed it to 3, we'd get it false, right? We just get items out of our list, right? So this is how you create a list, and this is how you access items inside of it. Again, think of it just as kind of like a grocery list, right? When you go shopping, you might create a grocery list where you write down things, and then you have that list and say, okay, what's the first item on my list? What's the second item on my list? What's the last item on my list? Speaking of which, really quickly, if you remember, strings had negative indexing where you can do negative numbers. And so you can do the same thing with lists. So my list, -1, just gets the last item out of the list. And here it's false. I can add more items to my list. I can put my name. And if I do that, then the last item is going to change. Right? It used to be false, but now I added another item. Now it's Jack. And since you can do indexing, you can also do slicing. So let's do an example of a slice. So my list, I want the slice starting at 1 and going up 2, but not including 4. So this is going to give me basically a section of my original list. Starting at index 1, so it's going to have the 2, and it's going to go up to, but not including the 4th element. And so Derek already put what he thinks should be in there, 2, hello, false. And if we just run it, you can see that's exactly what we get. Notice we get another list, right? So if you take a list and slice it, you get another list. But again, this should look pretty familiar so far, right? It's identical to how strings work. You can think of a string as actually a list of characters, if that helps, right? In some languages, that's actually how strings are implemented. Strings are not really their own data type. A string is just a list of characters. And since you see how lists are now, hopefully you can see why that would make sense. Here's an example of lists inside of lists. So here we create one list called Q, and then we create another list where Q is an item inside of it. Okay. And so you can get the length of P, and that's going to be 3 because there's 3 different things inside of the list. Then you can access P1, which is getting this Q out, which itself is a list. So you can do P1 and then access index 0. So again, P1 gets the second element, which happens to be a list. So you can index again, right? So you have a list, you access the element at index 1, that happens to be a list. So you can access the element at index 0. You're just chaining the accessing one after another. Again, this is a little bit more of an advanced topic, not too important right now. All you should just remember is a list is just a collection of items that has an ordering to them. So here, we're gonna go into a little bit about how to modify a list. So if you create a list and it has 5 items into it, and you realize you need to put another one in there, right? No worries, Python can adjust the length of the list as much as you want. You can add as many items as you want into it after you've already created it. So the way you do that is with this append function. And so since this is something specific to lists, you're gonna do the list.append. And then since you're appending something to the list, you need to take in a parameter. You have to know what you want to append in the first place. So here in this case, we have a list that contains the numbers 2, 3, and we want to append the number 5 to it. So if you can guess, well, you don't have to guess. We can actually run this. So if Q is a list 2, 3, and we do Q dot append the number 5, and then print out Q, you'll notice that it's the list 2, 3, 5. And I can actually do this over and over again. So for example, let's just do this a couple times. And if I run this, you can see I've appended another 5, and another 5, another 5, another 5, another 5, another 5, right? You can keep doing this as much as you want. You can append different values as well. So you can append, this is a list of numbers, you can append a string to it. There's no restriction to it. If you check the length of it, it will be increasing every time you append. Makes sense because you have another element in there. There's no real concept. Well, there is a equivalent concept, removing. You can remove from a list. And I might have a slide on it later, but if not, I can show it if we have time. You can also edit the things that are already in the list. So append is how you add new elements, but what if you want to modify the elements that already are in the list, right? So for example, let's just print Q. And this is what the list looks like right now. But what if I want to change this 5 to a 6? All right. I realize I don't want it to be a 5 anymore. I want to increase it by 1. And so what I can do is I can access the element. So that's going to be index 0, 1, 2, 3. So Q of 3. And I want to update this value. So I'm going to assign something to it. I'm going to say it's equal to 6. That's one way you can change it. And if you run this line of code, nothing shows up because all this is doing is changing the list. It doesn't output it for you. So to output it, you just print out the list again. And if you notice now, you can see the list is changed. Before it was a 5, now it's a 6. I can do the same for other elements as well. So like, for example, if I wanted to make this one negate this value, what I could do is find the index. So we know 6 is at index 3. So that's 4, 5, index 5. So Q of 5 is equal to -5. That's one way of doing it. But if you wanted to just negate the value, like you don't know what's there. So in this case, we already know it's a 5 there. But what if we don't know what the value is? Well, you can do it a couple ways still. You can just say it's equal to -1 times whatever was already there, right? So you take whatever was there, you multiply it by -1, and then you store it back into that position. So I can do that. And if I print out Q, you can see, boom, you have a -5 there. So to recap, you can create lists like this with square brackets, with elements separated by commas. You can access elements out of the list using indexing. You can get slices of the list using the slice notation, start index, colon, end index. You can append new values to the list. So this is taking an existing list and adding elements to it. And you can modify elements that are already there using things like this, right? With just assigning a value. I like to think of lists as essentially just a bunch of variables connected to each other. And so when you say like Q5, I like to think of it as the list is just a whole bunch of spots, a whole bunch of buckets. And you're just trying to get the bucket at index 5, and you're putting something in there. That's what this is saying, right? Q5 equals something. And what is that something? Well, that's whatever was there times a -1, right? Yeah. Sorry about that. Um, so I think that's really the basics of lists. We're gonna go into some more things that you can do with them. But at this point, does anyone have any questions about what I've done and what I've covered so far? It doesn't even have to be about lists if you have questions about something else. So I don't see any questions in chat. All right, so the next thing I want to talk about is something I skipped when we were talking about strings, and that's a very useful function that allows you to convert a string into a list, right? And so the reason why I didn't talk about it then is because we didn't know what lists are. And so since we just learned it, let's go back. So this is like a throwback to strings. There's something called the split method, which can take a string, cut it up, and put it into a list, put each part into a list. And so let's look at how it works. I'm going to make a string. Let's say S equals the string I love Python, just like that. Okay. And what I want to do is print out s.split. And if you notice, what is this doing? Can anyone tell me what is going on here? What do you think the split method does? Based on what I have here, and this is the result of it. Can anyone describe to me, explain to the class, what does the split function do?
For every space there is, they add a comma and replace it.
Close. It's not exactly replacing because the output is no longer a string. The output is now a list. But I like what you said. It finds the spaces, and what I like to think of it is it chops it up, right? So it finds every single space and it chops the string there. So it sees a space here, it chops that string into two pieces, one with I and one with love Python, right? And in that process, you get rid of the space disappears, right? And then you keep going. So then you have another space here. So you chop up love Python into love and Python, and the space goes away because you chopped it up. And now once you have the different pieces, you need some way of storing them together. And so what you do is you put them into a list. And so I see Charlie also put into a message. It's close. Again, important thing to notice is that here we have square brackets. And this means that what we have here, this is not a string. This is not a string with quotation marks and commas inside of it. This is a list. This is a list of 3 elements: I, love, and Python. Okay. And so by itself, split is a very, very useful function to turn essentially a sentence into the words that make up the sentence, right? So if I store this result into somewhere, so I can say x equals s dot split. Now I can access the different words of it. So if I wanted to get the word love, I just take my list and access the item at index 1, because if we look at our list, that's where love is. If I wanted Python, just do x2 and I get the string Python. If I want the string I can just do x1, right? Or oops, x0, should have said that, I. And again, this applies to really any string that you want. It just finds spaces, chops it up, and puts those pieces into a list. However, split is more versatile than that. So split doesn't have to just chop up spaces. You can also choose something else to chop up your string on. So for example, if my string is, I love Python, except there were hyphens instead of spaces, this wouldn't really do anything useful because it's looking for spaces, it can't find any, so it doesn't chop up anything. It just puts the whole string into a list. It didn't really help us at all, right? All it did is just put a string into a list. We can actually tell the split function what to split on, right? And so the way you do that is by putting a string inside of it. And so here, the input to split is whatever you want to chop up your original string based on. So now I want to chop up the string based on hyphens. And so if I run this now, it goes back to what I had before, right? Notice the thing that I'm splitting on, here the hyphen, does not show up into this section, right? So when you split the string on a hyphen, that means you also remove them at the same time. Okay. I could split my string on something else. I could split my string on O's if I wanted to. And if I split my string on O's, you'll notice this is what I get, right? Because there's an O here and there's an O here. So it chops those up and I get I hyphen L as my first part, VE hyphen PYTH as the second one, and then N as the last one, right? So again, split is really, really versatile. I'd say splitting on spaces is kind of the most common, just because it's so useful, right? It's really useful for turning a big sentence into individual words. You can also split on commas. That's sometimes really useful because in a lot of different file formats, you'll have values separated by commas. And so you just want to split by commas so you can get each value in a different cell in the array. Right. And so I wanted to talk about this because looking ahead, this split function will be very important for the homework for this week. So make sure you remember this. And yeah. The other thing I want to talk about before ending class today is sorting a list. So there's actually two ways. I'm going to do the first one. We'll see if we get time for the second. But here, so here, the first way to do it is the dot sort function. So a list dot sort sorts the objects in the list. And it has a default way of sorting items, but you can also tell it a function on how to sort the values. So this function, very important to remember, does not return a new list. It modifies the original one. So what happens is it will move around the items in the original list. Okay. And so here's what it looks like fully. You have some sort of list, you say dot sort, and these are optional parameters. You don't have to tell it anything, but you can say, I want to reverse the order. So instead of ascending, I get descending, or vice versa. And this key thing I'll talk about a little bit more later, but it is an optional input to basically describe how are you comparing the different strings to each other. By default, if you're sorting a list of strings, it's going to be by alphabetical order. By default, if you're sorting a bunch of numbers, it's going to be by their magnitude. So the negative numbers are less than the positive numbers. A larger positive is going to be later than a smaller positive. And it's ascending order by default. So let's look at that. Let's just create a list of numbers right? So I'm gonna say num list is equal to, and this is gonna be some random order. 5, 4, 1, 7, -3, -2, 6, 0. Right, so I have a list of numbers. And just to show that it is in this random order. Oh, that is not what I wanted to do. Num list. So here we just have a list of pretty random numbers. And so let's do the sort method. It's taking our list and then doing dot sort. And here, let's just not do anything yet. Let's just use the defaults for everything. So if we do this and run it, notice it's not very exciting. It didn't print anything out. It didn't return anything. And why is that? That's because we modified the original list. So now if we print out what numList is again, you'll notice that it's something different. You'll notice this is what it was before. This is what it is now. Notice it's kind of just how you'd expect it, kind of on a number line. You have your negatives and then you have your positives in increasing order. But I can sort the list in reverse order. So I can say numList.sort reverse equals true. So by default, it's false. And if I reverse it and print out the result, you'll notice that now instead of going ascending order, it's descending order. Okay. And let me make a new list. So let's make a string list. Because I want to show off the key parameter to the function. So let's say apple, peach, grape, banana, something like that. Hopefully my spelling is correct. And let's just print it out. So again, I can do the exact same things I just did. str list dot sort. Let's just do it by default and print out what it looks like. So again, like I said, by default for strings, it sorts in alphabetical order. So like A, B, G, then P. Right. Notice again, it modified my list. So if you want the original list to stay how it is, this is not going to help you. We will discuss a different way of sorting that does not modify the original list. And otherwise, they work exactly the same. It's just one modifies the original list, one leaves it alone. But here, now is where we can do the key parameter to the function. And the key parameter just tells us how do you want to sort the items by. And so again, by default, it's alphabetical order for the strings. But what if I wanted to sort based on length, right? And so that was on the slide, you might have seen it. But what you do is key equals, and then you just put the name of the function. So I want to sort based on the len function. And what this says is, hey, when you're sorting the list, you have to compare values. Hey, does this go first or does that go first? And so now when you're deciding that, you're basing it off of this function. So whether this string goes before the other one is based on whether the length of this string is before or after the length of the other one. And so if we do this, you'll notice this is not alphabetical order, right? Banana is all the way at the end. And that's just because it's sorting by length order. So apple, grape, peach, it just happens they're the same length. So maybe I can do a different one. I don't know, apple pie. And so here now, since that's longer now, that's at the end. This is clearly not alphabetical order. In fact, it's reverse alphabetical order just by chance. We don't know how to define our own functions yet, but if you did define your own function, you can change how the sort method orders elements. And so again, it's really useful in that way. By default, it's really good, but it's customizable. You can make it do other things as well. And this is another example with car names. So by default, this one is going to sort by alphabetical order. So I believe that's BMW, Ford, Mitsubishi, Volkswagen. And then if you do it this way, reverse equals true, key equals len, this is going to do length ordering. So if you just had key equals len, that'd be ascending in length order. But since you also say reverse equals true, you're going descending in length order. So that's going to be Mitsubishi number 1, Ford number 2, BMW number 3, and then Volkswagen number 4. If you don't trust me, you can run these on your own time as well. Right. So looking at the time, I do have time to go over the other one. So the other one that exists to sort lists is called the sorted function. And if you look at this, how it works, it looks almost exactly the same, right? You still have the key optional parameter. You still have the reverse optional parameter. But now the difference is instead of doing something dot sort, you're doing sorted and then putting the list inside as a parameter. It's the first parameter, the iterable. So this is a built-in sorted function in Python. You can sorted things that are not lists as well. And again, the difference is sorted returns a list. It leaves the original one untouched. The original list is still not sorted. It's the order that you gave it as. Instead, it will create a new list for you, and then you can store that into something else. So again, these are just two different ways of sorting lists. Very, very similar how they work. The only difference is, do you modify the original or do you leave it alone? So with that, I just have a couple of minutes left. So I want to get into the homework. I was looking over the homework for last week and they look good. Although I did notice that I wasn't getting as many submissions as I would have liked. So again, I really want to emphasize that doing the homeworks is really important to understanding the material. And that's just because the best way to learn is to practice and to get your hands dirty. These lectures are good. I know I've said this before, but 1 hour a week, there's a really large gap in between each class. And there's a chance that you forget a lot of what happened last week. And so that's really what the homework is meant to do, just to give you practice during the week as well. Please, I know you're also in school. In addition to this, I know you're busy. Try to spend 30 minutes sometime in the week to do the homework. I promise it shouldn't take more than 30 minutes. If you're having to spend more than 30 minutes, send me an email. I'd be happy to help out and help you solve the problem. Again, it's not for a grade. I do give a score just to show you that I looked at it, but it's not like I'm going to give you an A at the end of the class or an F. It's really just for practice.
I did my
But with that,
homework. I just forgot to submit it.
no problem. So if you submit it, I'll take a look at it sometime, probably right after this class or later this week. Yeah. So homework for this week is first, if you didn't do last week's, I would encourage you to do last week's as well. It might even be easier because we spent more time talking about Booleans today, which last week featured. But for the new stuff, we're having you take in 2 strings. You can copy these into your editor, whatever you'd like. And I want you to convert these strings into lists. And so that's going to be using the split function. I want you to print out the length of each list. So I don't think I emphasized it, but the len function for strings also works for lists. You can find the len that way. And then using a Boolean statement, I want you to compare the lengths of them and print out whether the first one is longer than the other. So that should be a true false answer. And then finally, sorting the list in reverse length order. And so this is very similar to the example in the slide. So if you want help with that, look there or reach out to me as well. But anyways, that's it. Thank you for sticking with me until 4 o'clock. That's all